Okay, the second part of our lesson is we're going to take a look at some key features, do a quick sketch of what we're given to decide which function the key features represent. So first of all, most all of these, the domain can be all real numbers, so not too helpful, but we do know we have a range and we know that the value of 2 is included, so we know that eliminates exponential. So I'm thinking it's got to be quadratic. So if we have a graph and the least value that our y can be is 2, then this means our graph has to go upward. So that means we have a positive a value. So this is going to be a quadratic with a minimum vertex. Okay, now we have in behavior, and as we go left on the graph, our graph gets closer and closer to 2, but it just approaches. And then as we go right, our graph goes up. So this has to be exponential. So if this is a value of 2 here, our graph will look something like that with an asymptote of 2. So this is going to be exponential, and this is going to be a growth. Okay, the next one, again, our domain doesn't really help us that much. Our range is from negative infinity, and it approaches 5, but it doesn't include 5. So let's take a look at this. If 5 is where it approaches, that is, so the least value is negative infinity, and then it gets closer and closer to the 5, but never reaches it. That tells me that we have an exponential, and we're really not, remember we talked about when it's a reflection, then we don't really consider a growth or a decay. So if this graph was reflected back to its original, it would have been a decay, but we're just going to call it exponential. Okay, on this in behavior, as we go left, our graph is going down. As we go right, our graph is going up. And since we're only considering these 3 functions and not like cubics, because this could have been a cubic, we're going to say that our graph is going to be linear and it's going to be a growth. It's going to have a positive slope. Okay, the last thing we're going to look at, well, we do have one more small item, but is the average rate of change. So this is going to take just a few minutes because we don't have a graph, we don't have a function table. So remember, our average rate of change is really just the slope of our secant line over the given interval. The given interval is the x values. So to find the slope of a line, you need 2 points. They're always going to be given the input values of both points. So now we're just going to plug in -1. And so we say 2 times -1 is -2. And then we have +3. So that's going to give me 1. And then when I put in 1, I'm going to say 2 times 1. And then +3, that's going to give me 5. So A rock is y2 minus y1 over x2 minus x1, and that gives us 4/2, which is 2. Now let's compare the quadratic. So we're going to plug in, let's write our points out. So both the input values are given to you. So we're going to plug in -1. So we're going to have -1 squared, so that's 1 times 2 is 2, and 2 plus 3 is 5. We're going to plug in +1. Again, it's going to give us the same output because we're squaring the same number. So that will give us 5. So we're going to go, let me check my work here. 1 squared, that it does. So we're going to have y2 minus y1 over x2 minus x1. That's going to give us 0/2. So the average rate of change was just the horizontal line. So that secant line was just a horizontal line. Okay, now we're going to plug in -1 here. So we have 2 to the negative 1, so that gives me just 1/2 because it reciprocates my base of 2. So we're going to have 3 times 1/2, and I'm just going to write it as 3/2 for now. Now we're going to plug in 1. So 2 to the 1 is 2, times 3 is 6. So we're going to say 6 minus, we can go ahead and just convert that to 1/2. And then we're going to have 1 minus negative 1. So 6 minus 1/2, if that was just 1, it would be 5. But we have another half, so 4.5 over 2. So 4/2 divided by 2. It's late, so we're going to use a little calculator here. It's like 11:55 at night. That is way past my bedtime. And that gives me 2 1/4. So 2 1/4. Okay, so out of these, we can see that the exponential had the greatest rate of change over this interval. But that doesn't mean that this is always the greatest. It depends on the interval we're given. So we're going to do this again, but this time we're going to have a different interval. So when we plug in 0 here, we're going to get 3. When we plug in 2, 2 times 2 is 4. 4 plus 3 is 7. And then we have 7 minus 3 over 2 minus 0. That gives us 4/2, which is 2. And we're always going to get 2 on this one because it's linear. And this is going to be our constant rate of change. No matter which interval we're given, it's always going to be constant, a constant of 2. Okay, so we're going to plug in 0 for x. That wipes that out. And so we have 0, 3. Notice these are the same y-intercept. And now we're going to plug in 2. So 2 squared is 4. 4 times 2 is 8. And 8 plus 3 is 11. So we have 11 minus 3 over 2 minus 0. So that's going to give us 8 over 2, which is 4. I'm sure somewhere in some of these videos I'm going to have made a mistake, so you guys know how it is. We'll correct it. Okay, we're going to plug in 0 for x. Remember, anything raised to the 0 power is 1. So that whole part of this term gives me 1. And then 1 times 3 is 3. Look, all 3 of these have the same y-intercept. That's the place, that's the one point that they all 3 share. Okay, now let's plug in a 2. So 2 squared. So we have 2 times 2 is 4. 4 times 3 is 12. So we have 12 minus 3, 2 minus 0. That gives us 9/2. So when we're comparing, we can look at this. So that's going to be 4 1/2. So again, the exponential, most of the time has a greater rate of change, but not always. So be careful with that. Okay, the last thing we're going to look at, we kind of already looked and we saw that when we plugged in 0, we got 3. That is our y-intercept. So when we plug in 0, it wipes that out, gives me 3. When I plug in 0 here, it's going to wipe that term out and give me 3. When I plug in 0 here, that gives me a value of 1, and then 1 times 3 is 3. So this is the one point where all 3 functions intersect.